is Dr. Bharti Patil, working as an assistant professor physics in Maharaja Jivaji Rao Shinde College, Srigunda, Ahmednagar. We have started our syllabus related to solid state physics and we have started our first chapter, that is the crystalline state. During our previous lecture, we have seen few of the points related to the crystalline state, and these are related to lattices. Now, in today's lecture, we are going to see the Bravais lattices which are present in two-dimensional system. As we know that if we try to organize points in a space, then it will give us a space lattice, and there are various arrangements by which a space lattice can be found out. We have already seen in case of three-dimensional lattice, that is there are 14 different ways to express the Bravais lattices. It means that 7 crystal systems can be organized in 14 different ways. Like that, now in today's lecture, we are going to see what are the Bravais lattices, which are the Bravais lattices which are present in two-dimensional lattice. And these are based on the relation between their lengths or the primitives A, B, C and the interfacial angles or interaxial angles. In case of two-dimensional lattice, as the lattice is having only two-dimensional dimensions x and y, therefore there are two lengths comes into the picture, and these are A and B, and there is one angle, that is interfacial angle theta. Now, by using this knowledge, we will see what are the Bravais lattices present in two dimension. Therefore, if we consider the lengths A, B and angle theta, then we will find 5 different types of Bravais lattices present in two-dimensional lattice. First is oblique lattice. Oblique lattice is a one in which the lengths A and B are not equal or same, and the angle between these lengths or the interaxial angles, one can say, is not equal to 90 or 120. What is oblique lattice? Oblique lattice is a lattice in which lengths are not same and angle not equal to 90 or 120, and this will give us a conventional unit cell like a parallelogram, and same is shown in the figure. A is not equal to B and angle not equal to 90 or 120. As we move forward, you will understand that why angle is not 120. Angle 120 is present in case of another type of unit cell. So we have covered here oblique lattice. Then square lattice. Which lattice in 2D is called as square lattice? As name suggests, square lattice is the lattice in which both lengths will have same measurements, that is A is equal to B and angle between them is 90 degree. Therefore, unit cell which will have A is equal to B and angle is equal to 90 degree is called as square lattice. Then hexagonal lattice. In case of hexagonal lattice, there are the two lengths along A, along X A and along Y B. Then the lengths are such that A is equal to B. Then A is equal to B and angle between these two lanes is equal to 120. Angle between them is 120, and such type of lattice is called as hexagonal lattice. A regular hexagon is formed when all the nearby lattice points about a given lattice point O are connected as indicated in figure. Figure is shown here, and the primitive cell is rhombus of 120 degree. Hence, What we can conclude? Hexagonal lattice is a lattice in which both the lengths are same and angle between them is 120 degree. Now our fourth Bravais lattice in two dimension is called as rectangular lattice. It is also a simple type of structure because we know that rectangular is a figure in which the lengths are not same, that is A is not equal to B and angle between them is 90 degree. Such type of structure is called as rectangular structure and lattice is known as rectangular lattice. If we observe this figure, then what you are observing, that is the length A is less than length B. It means that we are having a freedom to increase length A or B, means A greater than B or B greater than A is going to give us a rectangular structure. But in case of this simple rectangular lattice, A is less than B, and this is called as conventional rectangular lattice. So, while summarizing, a rectangular lattice or a conventional rectangular lattice is a lattice in which A not equal to B and theta is equal to 90 degree, where A and B are the lengths of unit cell of a rectangular lattice and theta is the angle between these two lengths. Now our last Bravais lattice, which is present in two dimensions, is called as centered rectangular lattice. Why it is important to know whether the A is greater than B or B is greater than A in case of rectangular lattice, you will come to know here. Because when A is greater than B in a previous case, then there will not be an extra atom which is located at the center of unit cell. But if you observe this figure, then what it indicates, that is A is greater than B. When A is greater than B, then there will be extra atom which is located at the center of rectangular, and this is called as center rectangular lattice. It means that center rectangular lattice will have A not equal to B and angle between them is also 90 degree, but here A is greater than B. So the conventional unit cell is a rectangular with the additional atom at the center of unit cell. Thus, in our today's lecture, we have covered the points related to two-dimensional lattices in Bravais lattices in two dimensions, and these are oblique lattice, square lattice, hexagonal lattice, rectangular lattice, and center rectangular lattice. Hope you have understood today's lecture. Thank you.